Since I'm going to be gone today, you're going to have a video that's going to go over your notes. What I want you to do first is go ahead and do these two problems right here. You're going to sketch the graph of both functions. There's more graph paper up at the front if you need it. Graph each function and then identify your important information that was related with each of them. So on your absolute value function, you're going to give me your domain and your range. On your quadratic function, we added a couple more. So you're going to do your axis of symmetry, you're going to do your vertex, as well as your domain and range. So go ahead and pause the video so you have enough time to do that, and then play it again when you want to check and make sure you've got the right answers. So looking at our absolute value function first, again, we always think about what our transformations are doing, what we expect to see. Looking at this one, the x minus 2 tells me my graph's going to go to the right 2. And it's going to go down 3 because of that minus 3. So that's where my vertex is going to be at, is at positive 2, negative 3. From this 3 in front, it is positive, so my graph is going to be opening up, not down. It does not flip over, since that first 3 is positive. And it's going to have a slope of 3. Make sure with the 3 that you count up 3 and over 1. It is rise over run. And so this will give me my points to open up 3. I can also count some off to the left. Okay, but this is going to be my absolute value function. Oopsies. So that is what your final graph should look like for that function of g of x equals 3 times absolute value of x minus 2 minus 3. And if you look at it, it does go to the right 2 and down 3, and it is vertically stretched like we expect. For your domain, there is no restriction on what you can plug in, so it goes from negative infinity all the way to infinity. For your range, since there's a bottom, I'm going to have a number down here. The lowest I can get out of my function is negative 3, but the highest is a positive infinity, so it goes from negative 3 to infinity. Okay, on the second one, again, we're thinking about what it looks like. This tells me x minus 1 tells me it's going to go to the right 1 and then down 1 because of this other 1. So my vertex is right 1 and down 1. It is right here at 1, negative 1. My axis of symmetry then is at x equals 1. It's the vertical line through that point. So I'll go ahead and fill that line in just so we can visually see it. That's our axis of symmetry that we will use when we're plotting our points. Remember, when you're plotting these, you're going to pick two numbers, either from the right of your axis of symmetry or from the left. It does not matter which side you pick them from, as long as you are plugging them in correctly. So if I pick 2 from the left, I can pick 0. So then when you plug it in, it's going to be 0 minus 1 is negative 1, squared is positive 1. When you multiply that positive 1 by a negative 1, you're going to get negative 1 minus 1, which is negative 2. If I go to plot that at 0, we're at negative 2, but I can also reflect it across this line, and so at 2, I'm also at negative 2. If I plug in negative 1, so again picking 2 from the left, negative 1 minus 1 is negative 2, squared is a positive 4, times negative 1 is a negative 4 now, and then negative 4 minus 1 is negative 5. So we got a negative 1, negative 5, and then I reflect it over the line as well. And this is my function. Always keep in mind if it looks like what you expect it to look like. Sorry, I missed that point right there. Let's go. Okay, it is flipped over, which we expected. It is moved to the right and down, and so it is exactly what we expected from it. When I go to my domain, there is no restriction on your domain, so negative infinity to positive infinity. Okay, there is a bottom. There's not a bottom on my graph. I've got arrows down here, so it goes from negative infinity all the way up to negative 1. The negative 1 is that maximum on my graph, and that's where the graph stops at. Okay, here are your homework answers. Make sure you have a pen so you can check them and have the right answers for each thing. Go ahead and pause this to check whatever you need to check on these as you go through. Scroll down a little bit. Okay, on these, do make sure that you have identified your axis, symmetry, vertex, domain, and range. Your domain on every single problem is from negative infinity to positive infinity. Okay, on this problem, on number 5, my vertex is at negative 1, negative 1. My axis of symmetry is at x equals negative 1. and my range is from negative infinity up to negative 1. On number 6, your axis of symmetry is at x equals 3. Your vertex is at 3, 0. Your domain, like I said, is negative infinity to positive infinity, and your range goes from negative infinity to 0. So that should be a bracket. Again, feel free to pause this as you go through so you can check the graphs longer. I'm just going to go through what should have been the extra answers. Here, my axis of symmetry is at x equals 3. My vertex is at 3, 2. And my range goes from 2, because that's the bottom, all the way up to infinity. On number 8, your axis of symmetry is at x equals 0. Your vertex is at 0, negative 2. Your domain is negative infinity to positive infinity, but now your range goes from negative infinity all the way up to this negative 2. That's the maximum on my graph. Going on to the next ones. Your axis of symmetry is at x equals 3. Your vertex is at 3, 0. Your domain is negative infinity to positive infinity. Your range is negative infinity to 0. Number 10, your axis of symmetry is at x equals 1. Your vertex is at 1, negative 2. Your range goes from negative infinity all the way up to negative 2. Going to the last two, your axis of symmetry is at x equals 2. Your vertex is at 2, 1. Your range, since again that's the only thing that changed, goes from 1 all the way to infinity. For the last one, x equals negative 1 is your axis of symmetry. Your vertex is at negative 1, negative 2. And your range goes from negative infinity all the way up to negative 2 at your maximum. Okay, keep these homeworks. We will go ahead and check them next time, but I want to make sure you have the correct answers before we move on to the next lesson. Today you're going to cover piecewise functions. Go ahead and make sure these directions or the title is in your notes so that you have it. Again, feel free to pause this video at any point so you have plenty of time to write things down. We've already talked about piecewise functions a little bit on day 1. Piecewise functions are functions that are defined by multiple functions. These are always going to be restricted on your domain, so it is based on restrictions to your domain. So these are the functions where I'm going to give you 3 different functions, and I'm going to tell you which x values they apply to. And you're going to graph these for me so you can visually see what's happening for each function. You're going to dive right into graphing these. So go ahead and make sure we're going to fill in some steps while we talk it through. Okay, and we are also going to graph this one together first. Make sure you have plenty of graph paper. And go ahead and write down this piecewise function. When we graph these, you are going to be graphing each function individually. Okay, usually when you graph, you extend your lines forever, you put arrows on both ends, and all of that is because you can graph it forever for the things you guys have learned to graph so far. However, today we have limits on what part of the graph we're going to graph. Especially at first, one thing that helps is doing this in pencil, graphing the entire function that you're used to, and then erasing it so you only have the piece that your function wants to talk about. So I do recommend using a pencil when you go through these, especially at first. Okay, so we're going to graph each of them individually first. If I want to graph this first one, this is the line f of x equals 5, or as you guys have seen it before, y equals 5. Your y equals lines are always horizontal, so if I were to draw the entire line f of x equals 5, this is what it would look like. Okay, however, it is restricted. So once you've graphed it, we're going to do them one at a time. You are going to erase the portion of the graph that is not within the restriction, the domain restriction. And what I mean by that, f of x equals 5 only if x is less than -4. So I only want the portion of my graph that is less than -4. Remember, your x's are along this axis right here. So we're going to find -4, and this is where my graph should start at. Okay, so I'm going to shrink this down so that it only shows up on the left of -4. Okay, that is completely based on this restriction up here, but you would erase this whole right portion of that graph. Okay, as you get better at this, you will start to only graph the relevant parts, which will be wonderful, but while you're getting used to it, it's okay if you have to erase a bunch. The last thing you got to think about while you're graphing each of them, is your boundary point. And on that boundary point, you are either going to have a closed circle or you are going to have an open circle. And that is determined exactly the same way as when you did it in Algebra 1 with your inequalities. If it is a closed circle, that means that your inequality was less than or equal to or greater than or equal to. It has the equal to part under it. It's telling you it includes that point. If it is open, then it is either less than or greater than. Okay, so on this one, I'm going to make sure to go ahead and fill in a closed circle right there on that 4, since this is less than or equal to -4. Okay, once you've done one of them, we now have to do the other two. So then we're going to graph this function, the absolute value of x plus 3. When we do this, we're going to think about our transformations just like before. This is a absolute value function that was moved to the left 3 units because it says x plus 3. So when we graphed these, that meant my vertex was over here at -3. Okay, then it has a 1 in front of it, so the slope is 1. It's positive, so it opens up. So my graph would originally look like this. I'm going to use my line so that it's a little bit prettier. Whoopsies. Okay, so my line would go like this if I were graphing all of the function. Okay, this is what it would have looked like yesterday. However, now like before, I have to pay attention to the region I actually care about. We have to be greater than -4, which means I don't want any of this that's to the left of -4, so I'm going to erase this portion, bring it all the way back to the -4. And I want to go all the way up to where x is equal to 2. So on my graph, this is where x equals 2, so at the +2, wherever that intersects, is where it should stop. So you are erasing it, so the only part of the graph you can see is from -4 to +2. So that is the only portion of the graph I kept. You erase what's to the left and to the right of that. Once you have that, you're thinking about your boundaries. The -4 should be an open circle because that tells me that at -4, it really equals 5. It doesn't equal this +1. And at 2, since there's that line there, it's going to be a closed circle. Okay, then we're going to graph the last graph. The nice thing with this one, it's the exact same as our first one. So we're going to go ahead and just draw in this y equals 5 line. We know that it's only where x is greater than 2, so if you want, you can just go to where x is greater than 2 and draw that line in there. If you do it that way, you do not have to graph it. Do make sure we're going to have an arrow on this end because it doesn't give me an upper boundary. Since it is sharing that point there with the blue function, you don't have to draw that open circle since they overlap and it's the exact same point. But this would be the final answer to that question. Going to the next one, go ahead and write this down. We're going to go ahead and graph it. Sometimes you're going to have 3 functions, sometimes you're going to have 2 functions. It all just kind of depends on what I give you. So if we follow through our steps, originally we're just going to graph the function. So if I'm graphing negative absolute value of x, you were not shifted left and right or up and down. Okay, this would just be your function if I'm filling in some dots. It's flipped over, and there it is. But one thing that I think about while I'm putting my dots, just to kind of help if you're not a fan of erasing everything, okay, while I'm putting the dots, I think about my restriction. So this tells me that x is less than 1. So I know immediately that this is where my graphs switch. Okay, so everything to the left of the graph, since it's less than, will stay, and everything to the right, I'm going to. So what we can do is go ahead and erase these couple points that we have to the right of 1, and we're going to keep everything to the left because it is our less than negative 1, less than that x equals 1 value. When I go ahead and graph it, I'm going to have my v, do extend this one. There's an arrow over here because it does keep going. Okay, since there is a less than and there's no equal to under it, do make sure that this is an open circle on 1. So make that clear that this is an open circle right there. When we go ahead and graph this one, I gave you this one on purpose. Even though it looks funny, this is really the same exact thing as a half times the absolute value of x. So remember, there hasn't been shifted left or right or up or down at all, so my vertex is at 0, 0. The only thing that really changes is this half is your slope. So remember, from 0, you're going to count up 1 over 2 because your graph is wider. Okay. I know that my graph, get a line, would look like this on the right side. Okay, what you do have to make sure it is only where x is greater than 1, so you are going to erase. So, since this graph only is where x is greater than 1, we are going to erase that little portion between the vertex and 1, and your graph is going to go on from there. Since it is equal to, do make sure that that is a closed circle on 1. Okay, so this is what your graph would look like when you were finished. Go ahead and write this one down and give it a try. Pause the video long enough that you can get all the way through it, and then go ahead and start it again so you can check it. There is one thing that you're going to have to make sure you remember, and that is how to graph these lines. This is slope-intercept form, so remember y equals mx plus b, where m is your slope and b is that y-intercept. But go ahead and pause the video so you have a chance to give this one a try. Okay, to graph that top one then, we're going to just start and go top to bottom. My intercept of that equation is at a positive 1. My slope is a negative 1, so you could count down 1 and to the right, or you can count up and to the left, but give yourself a bunch of points. As you are making those points, this is when it's helpful to be thinking about which ones you actually care about based on your restriction. This tells me x is less than negative 2, so any of my x's bigger than negative 2, which are going to be these 3 right here, I'm not going to end up using. Okay, I only want the points to the left of negative 2. It does help to plot those beginning ones because that's how you know how to graph a line, but you are then going to end up erasing them. Okay, when I fill in my actual line, I'm going to start there and draw it on back. Do make sure that you have an arrow, and then make sure it is obvious that it is an open circle. See, we've got to draw it huge like that. An open circle on negative 2. Okay, then we're going to graph our middle line. It has an intercept of 0 since there is nothing added there, so I'm going to start at 0. And it also has a negative 1 slope, so I can kind of count this in a very similar way. Okay, and while you're doing it, be thinking about your restriction. This tells me it goes from negative 2 to 4. So I want all of these points in the middle all the way up to 4. This is where you can stop counting if you want to, because I would go past 4 on the x-axis. Okay. If it helps, keep graphing it. That's totally fine. But remember that you will erase those points when you're done. Okay. If I go ahead and fill this in, there is my line. Both of my boundaries have an equal to, so I'm just going to make it clear that those are closed circles on both of those points. And that's your second function. Okay, Last but not least, I have x minus 5 squared. So thinking about this one like we did before, this graph was moved to the right 5, which means my vertex and my axis of symmetry is at x equals 5, and my vertex is at 5, 0. So I'm just going to go over here and plot that vertex just like before. Okay, since this is your axis of symmetry, pick 2 points on either the left or the right. So if I pick the right, I'm plugging in 6 and 7. If I plug in 6 to this function, 6 minus 5 is 1, squared is 1. 7 gives me 7 minus 5 is 2, squared is 4. So I'm just going to plot 1, and then at 7 I'm up at 4. You can reflect these over as well, and if you notice, 4 is included, 4 is my boundary, but 3 is in my other region. So you can reflect the 7 over, the point from 7 over here, but you will end up erasing it because it's not greater than 4. So it's up to you of whether you plot that or not. Okay, do make sure you're thinking about those boundaries. But I'm going to plot the portion of the graph that I can see, and this is what it would look like. Okay, make sure this is x is greater than 4, so this needs to be an open circle. Okay, there's a lot going on in these graphs, so make sure you're paying attention. You're graphing your functions, and then you're erasing so that you only have the appropriate region left over. We'll go ahead and try one more, just to make sure you have plenty of practice, especially with your linear functions. Do try this one, and then pause the video so that you have enough time to try it. If I'm graphing this top one, it has an intercept of 0 and a slope of 1. Okay, so I'm just going to plot some points where you count up 1 and over 1, or down 1 and left 1. Okay, again, think about your regions and what makes sense. My domain restriction on this is that x is less than -3. Well, this is where -3 is at, so I'm not going to use any of the points to the right. You need them to help start to plot your line based on how you know how to graph it, but you are going to end up erasing all of these x values that were to the right of 3. Now that I've got this, I'm going to go ahead and fill in this line right there. Okay, x is less than or equal to 3, so I'm going to make sure that that is clearly a closed dot, and there's an arrow over here because it just keeps going. When you're looking here then, -3 is a horizontal line at -3, so that's right around here. Okay, it goes from -3 to 1, so while -3 goes the whole way across, I only care about this little region right here from -3 to 1. So I'm just going to draw that graph in there now. Oopsies, so right there. Okay, again, you can graph the whole thing and then erase what you don't care about, but remember your boundaries. Since this point overlaps, it doesn't matter if it's going to be closed because it was closed on the first one. At 1, it's also closed, okay, because of that equal to. Last thing to do is go ahead and plot this graph. So we're going to start with our intercept at -2, up 2 and over 1, up 2 and over 1. Paying attention to where I expect it to be anyways. It's going to be x is greater than 1. So I need to go to the right. When I'm looking at this, since x is 1 here, I don't need anything to the left of that point. So this is the part of my function that I care about. I'm going to go ahead and draw in this line. Okay, it does get an arrow to the right because it keeps going on forever. At 1, it's not equal to, so I'm just going to put an open circle. I apologize. I'm going to make that clear that that is an open circle. And that's the rest of your graph. Okay, the last thing we're going to talk about today is your word problems. On some of your word problems, you're going to graph it for me, and on some of them, you're just going to write me the equation, but the graphing stays exactly the same. So the one I have in here for you, you're literally just going to write me the equation. So go ahead and write this paragraph down, pause it so that you have time to do that, and then press play again when you are done so that we can go over how you would set this up together. Okay, we are going to write an equation for both of the different scenarios that are happening. Okay, and so we have to kind of break this down so we know exactly what's going on. You have your function f of x. There are multiple scenarios happening. So what I notice, it's 45 no matter what. Okay, so that's always going to show up. But it changes based on whether you have the car for 3 days or less, or if you have it for longer than 3 days. So I have two scenarios, longer than 3 days and 3 days or less. Those two scenarios mean I have to have a piecewise function. So we're going to write it for each scenario. First one we're going to do is for if you have your car for 3 days or less. If you have it for 3 days or less, there is a flat fee of $45. Okay, so that is your constant that does not change. However, you will pay $7 per day. Okay, so we have to do 7 times how many days, or our x, to figure out how much that daily cost would be. Once you do the 7x, you're going to add 45. And this would be your first part of your function. So the 7x comes from the daily fee. The 45 is your constant. That doesn't change. It is a flat fee no matter what, so it's just added on at the end. Then you do have to tell me what x's this applies to. Looking at the problem, it's for when you are less than 3 days, so x is less than 3. 3 days or less, I apologize, so x is less or equal to 3. Pay attention to that. So since it is 3 days or less, that 3 is included, so x is less than or equal to 3. If you have it longer than 3 days, it is now only $5 per day. So instead of doing 7 times x, it is now 5 times x, and you still add in that $45 late fee, or flat fee. Now that is just no matter, once you are longer than 3 days no matter what, so this x is greater than 3. Okay, you absolutely could graph this. However, here we're just going to plug it in and see what f of 3 is and what f of 4 is to figure that out. Here f of 3 gives you, you plug it into the top one because that's where that one's equal to 3. F of 3 is 7 times 3 plus 45, which gives you $66. Okay, if you did f of 4, that forces you to use this bottom function because 4 is greater than 3. So you're going to do 5 times 4 plus 45, which equals $65. Regularly with scenarios like this, when you're dealing with businesses, they often provide you with a discount at higher days just to incentivize you to actually rent the car for longer, which is why this 65 is cheaper, because then they can get people to use their cars longer and word of mouth to help promote their company. So this is a very normal scenario to see, and this is how you would figure it out based on your different piecewise functions. Okay, you're going to have the rest of class to work on your homework, and then we will check that next time and go over any questions that you have.